So what is a capacitor? A capacitor is a device that stores charge. And you find them, for example, in flashes, like on a camera, in TVs, in different medical devices, etc. The simplest capacitor is a parallel plate capacitor. And that consists of two plates, one that has a positive charge, one that has a negative charge. And they are separated by some kind of dielectric material like paper or air that can be polarized. And you basically connect this to a battery, and as electrons flow, they build up on the surfaces of one side, which induces a positive charge on the other side. And there's only so much charge it can hold because it depends on the area of the plate and a quality of the material called the capacitance. So, and that is going to be measured in units of coulombs per volt. So, with that in mind, let's talk about capacitance. So, capacitance is how much charge each volt will store, okay, in that material. So, every volt that you apply to this capacitor, it can, depending on the materials that are used and how big the material is, it can store a certain amount of charge. So capacitance is the coulombs per volt that the capacitor plate can hold. And it's related to this value, this constant of the universe called the permittivity of free space, which is 8.85 e to the negative 12 coulombs per Newton's meter squared. And that is also multiplied by the area in meters squared divided by the distance between the plates in meters. So notice that if we look at this set of equations, that if you double the distance between the plates, the relationship between the distance and capacitance is an inverse relationship. So as you increase the distance, the capacitance will do the exact inverse, right? So if you double the distance, the capacitance will be 1/2. If you cut the distance between the plates in half, the capacitance will be twice as much. And if you double the area of the plates, the capacitance will be doubled because capacitance is proportional to area, right? Whatever you do to the capacitance, that will happen to the whatever you do to the area of the plates, the more capacitance it will have because it can hold more charge. And if you cut the area in half, then the capacitance will be 1/2 as much. So capacitance is inversely proportional to area and, to distance, and capacitance is proportional to area, right? So what charge is stored on a 130 microfarad capacitor? So let's just talk about what a farad is. A farad is the same thing as a coulomb per volt. Okay, that's what a farad is, and that is the unit that we use to measure capacitors in. Remember that micro is e to the negative 6. So our capacitance is 130 e to the negative 6 farads. And the voltage is 330, and we want to know what the charge is. So the formula that we want to use is C equals Q all over V. So Q is going to be equal to C times V, or 130 e to the negative 6 coulombs per volt times 330 volts. And our volts go away, and our charge is going to be 130 exponent negative 6 times 330, 0.0429. So this can hold 0.0429 coulombs of charge. So the parallel plate in capacitor in the next problem has an area of 1.05 meters squared, and it has a distance between the plates separated by 1.80 millimeters, or e to the negative 3 meters. And we want to know what the charge is that it can hold if it has a voltage of 2.10 e to the 3 volts. So remember that capacitance is equal to Q all over V, or epsilon naught times area all over D. And what we want to know is the charge. So we're going to be actually using this relationship here, and we're going to solve for our charge, which is going to be epsilon naught times area times voltage all over D. Epsilon naught is 8.85 e to the negative 12 meters all over Newton coulombs, meters squared all over Newton's coulombs. Actually, I just did that backwards, meters squared all over coulomb. And that's going to be times the area, which is 1.05 meters squared, times the voltage, which is 2.10 e to the 3 volts. And then I'm going to divide this by a distance of 1.80 e to the negative 3 meters. So this is going to be 8.85 exponent negative 12 times 1.05 times 2.10 exponent 3 equals, divided by 1.80 exponent negative 3 equals 1.08 e to the negative 5 coulombs.